Now, I want to keep my equation up here because we're going to draw N2 plus 3H2, and we're going to show that we can make 2 NH3s from that. Now, if you felt confused by this, or you didn't get it during your do now, or yours is incorrect, then you can follow along with us now and correct yours. Okay. So my nitrogen is going to be blue, and my hydrogen is going to be orange. Now, how many N2s do we have in the balanced equation? You just call it out. How many N2s do we have?
2.
How many N2s do we have?
1.
So we have 1, and that molecule has 2 nitrogens. So I want to show that these are bonded together. I have 2 nitrogens bonded together, but it's 1 molecule, 1 and 2. Okay, so if you do them separately, redraw them so that they're together. Now, how many H2s do we have? 3. Now, I know that's 6 hydrogens total, but every 2 are bonded together. So I have 3 H2s, so let's draw that. Each one of these is a hydrogen. And we're going to put these together in a container, and they are going to react. They're going to bond with each other. Now, our product is NH3. In NH3, I want 1 nitrogen bonded with 3 hydrogens. So I'm going to take one of my nitrogens from my reactants over here, and I'm going to bond them with 3 hydrogens. 1, 2, 3. Label NH3. Now, when I did this, I'm going to take the reactants and I'm going to cross them off. And I saw a lot of people not cross off their reactants when they made their products on your visualization from your homework. But we've used them. So I want to show that these now are gone. Because now they've made NH3, that they're not there in the reactants anymore. So if you didn't cross them off because now we can see what's left over to react. Shara, did you have a question? Did you have to draw them like this?
Like the product, do we have to draw product?
You had to draw 1 nitrogen bonded to 3 hydrogens because this is NH3. So because that compound is 1 nitrogen for every 3 hydrogens, then it should look something like that. Yeah.
So, like, for our product, when you kind of like wrote it, what it reacts to, why in the visualization would we have 1 nitrogen there when in our coefficient has 2?
Right. So if we look at our reactants, are we done reacting? Can we make more NH3s from this? How many more NH3s can we make from our reactants? 1. Right? I can take this N2 and bring it over and react it with my leftover 3 hydrogens. So that is my other NH3. Okay. And so we can see that from these reactants, we can make 2 NH3s. So I use these up, and now they are reacting. So that's what we mean by visualizing what's happening. So did we use all of our reactants? Yeah, right? We got all of them reacted. That now I don't have any excess. Okay. Now, next part, we're just going to look at container A. I think this threw you off because I gave you moles instead of grams, and so you did something opposite of what we did before, but I was impressed by some people who figured it out. Now, let's go up here. In container A, we are going to do this reaction, but we are given a certain amount of N2 and a certain amount of H2. Now, we want to know how much these weigh. Now, this is giving you how many N2s that you have. So it's like saying you have 5 calculators. How much do they weigh together? Well, what do you need to know in order to figure out how much all those calculators weigh? If I say you have 5 calculators, how much do they weigh? What do you have to know, or what do you have to do to calculate the total weight of those calculators? Hands, people, hands. You have 5 calculators. What do you have to do, or what do you have to know about those calculators to find out how much they all weigh together? Sierra?
You need to know how much one was as 7.
Good. So let's say